Okay, so this is the video you should be watching for week 8 live sessions. Okay, the goal of this is for you to watch the video, look at the material for 31333, and then come to the live session with questions. Okay? Now if you watch the video and you get stuck, write the question down somewhere, and at the end of the video you can email me, or you can wait until the live sessions to ask me. Alright? So, let's begin. Okay, announcement. Okay, due dates. Unit 6 must be completed by January 17th for the semester change. Okay, Unit 2 projects and tests. So basically, Unit 1 and Unit 2 is due the 18th. Still a couple hours. And 3.1 through 3.3. Part 1, lines and angles, is due a week from today, this Sunday. Okay, so it's due October 25th by 11:59 p.m. Okay, so a couple quick vocab words for you. Two lines are perpendicular if they meet at 90 degrees or a right angle. Okay, important, the small square must be drawn, or an angle must be given as 90 degrees in order for you to know the lines are perpendicular. So here, I tell you that it's a right angle. You cannot assume it is a right angle. Okay? Now, if that right angle is not there, then they look perpendicular, but you cannot assume that they are. So, because I give it to you, you can say that AB, line AB, is perpendicular to the line CD. Okay, I can't write all that there in the little box. I got to begin writing. Okay, and line M is perpendicular to line N. Okay, now you need to know that this here is a perpendicular sign. Okay, so if you see that sign, that means perpendicular. Just like this sign means congruent, this sign means equal, this means perpendicular. Okay, parallel lines are two or more lines that line the same plane and never intersect. Okay, and you also remember in the prelude here, they have the same slope. Okay. To show that lines are parallel, arrows are used. So notice here, let me highlight those arrows for you. See here the arrows, okay, within the line, not at the ends of the line, but on the line. Okay, so this means that line AB is parallel to line MN, or line N is parallel to line M. Okay, so again, another piece of notation here, right? So we have notation for lines. Okay, notation for a line, notation for congruent, notation for equals, notation for perpendicular, and our notation for parallel. Okay, so make sure you remember all this notation because you're going to see it. Okay, and then also angle notation as well. Alright, so that's notation so far we've talked about. Okay, and skew lines is probably the one you haven't heard of before, are lines that are in different planes and never intersect. Okay, different planes and never intersect. They are different from parallel lines because parallel lines are in the same plane. So for example, what are some lines that are skewed to each other? Well, AC, line AC, or segment AC in this case, is skew to EF, right? Okay, these lines exist in different planes and never intersect. Okay, how about another one? How about AB and FH? Okay. Or you can say AB and GH. Okay, because those lines never intersect either, do they? Okay, so those are just some examples there of what you could use. Remember, skew lines are like parallel lines, but in different planes. Okay. A transversal is a line that intersects two other lines. So if we're going to identify the transversal in each of these, okay, here, these lines here, we can't assume they're parallel, but they look parallel, but we can't say for sure that they are because there's no arrows. The transversal here is T because this is the line that intersects these two at two distinct points. So, line T here. Here, remember, the transversal line intersects two of the lines. So here's two lines. Okay, and here's a line that intersects two lines, right? Boom, boom. Alright, so here it would be line P. Yes, line P is the one that intersects two lines. Alright. So now some more vocab. Okay, this unit is very vocab heavy. Okay, same side interior. Angles that are on the same side of the transversal and are both inside the pair of lines. Now, okay, I'm gonna go back for 1 second here. Okay, I give you two parallel lines, right? Assume that I'm telling you, these two lines here are parallel with each other and are cut by this transversal. Okay, that forms 8 angles here. Right? Now, if we're going to talk about interior and exterior, the best way I like to describe it is to draw like hamburger buns, okay? Here you have a bun, here you have a bun, and here you have a burger. Okay, when you eat your hamburger, the buns go on the outside or the exterior, and then your burger is on the interior. So that means angles 2, 3, 5, 8, those are interior. In this case, 1, 4, 7, 6, exterior. So here, same side interior, angles that are on the same side, the transversal. Okay, remember, if I have a transversal, here's a transversal, right? Those angles are going to be supplementary. Okay, so I'm just going to put add 180 here. Okay, those are supplementary. And sometimes they're referred to as consecutive interior. I will always call them same side interior though. I go with same side, not consecutive. Okay, alternate exterior. Okay, those are angles that are both exterior to the parallel lines and on alternate sides of the transversal. So if I draw my buns, you can see that these are both on the outside. These here are congruent to each other. Right. Alternate interior, these are both interior to the parallel lines and on opposite sides, or alternate sides if you will, and those are parallel to each other. I mean congruent to each other, my bad. And corresponding, okay, here the parallel lines, they're on the same side of the transversal, on one's interior, one's exterior. Now the way I think of it is a copy paste. Right? If I was to copy this top angle, pick it up and paste it below, they will lie on top of each other. Okay, and these are also congruent. Okay, so we have same side interior, supplementary. Alternate exterior, alternate interior, and corresponding are congruent. Okay, so I just went over this. Corresponding angles postulate if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Alternate interior angles theorem. Alternate interior angles are formed by two parallel lines and a transversal, and they're always congruent. Alternate exterior are congruent when two parallel lines are cut by a transversal. And the same side interior angles theorem, aka consecutive interior angles. If two parallel lines are cut by a transversal, then the same interior angles are supplementary. Again, I kind of just went through that on the last line. And then don't forget, linear pairs are supplementary and vertical angles are congruent. So again, very vocab heavy day today. Week. Okay, we have 1, 2, 3, 4, 5, 6 different vocab words, and I could also talk about same side exterior if I wanted to. Okay. So let's practice now. Okay, using this diagram, using the corresponding angles postulate. Okay, corresponding angles postulate. Find the value of angle 5 when angle 1 is 140. Has 40 degrees. Well, those two, they're in the matching sections, right? So if I copied this angle, picked it up, if I copied these 4, copied all 4 of those, and picked it up, and put a paper on line M, there'd be matching corners, right? So therefore, the measure of angle 5 is going to be 40 degrees. Because those are corresponding angles, and they're congruent. Alright. Number 2, use alternate interior angles theorem to find the value of x when angle 6 equals 5x and angle 12 equals 35. So you know the alternate interiors means they're congruent to each other. So I'll have, come on, okay, I'll have 5x equals 35 divided by 5, and I get x equals 7. Okay, because alternate interior angles are congruent to each other. Corresponding angles are congruent to each other. I feel a sneeze coming on, so if I sneeze, please, ignore that. Okay, and number 3, use the alternate exterior angles theorem. Alternate exterior angles. Excuse me. Okay, alternate exterior angles to determine the value of x when angle 1 is that and angle 2 is that. Okay, alternate exterior angles congruent to each other. So we have 20 plus x equals 3x minus 40, and you would solve this equation. Okay, we should be proficient in algebra 1. Okay, so here I can subtract the x. And I get 20 equals 2x minus 40. Okay, I can add the 40 to both sides. I get 60 equals 2x divided by 2, and x equals 30. Okay, let's continue. Okay, use same side interior angles. Now, same side interior, okay, those add to 180 degrees, or otherwise known as supplementary. So you determine what the value of angle 3 is when angle 8 is 100. So angle 3 and angle 8, those are same side interior. So we just do 180 minus 100 equals 80 degrees. Okay. Number 5, use the vertical angles theorem to determine the value of angle 2 when angle 4 is 110. So as you can see, 2 and 4, those there are vertical angles and they're congruent, so the measure of angle 2 is going to be 100 degrees as well. Alright. And number 6, use the linear pair theorem. Okay, remember linear pair, that adds to 180. And vertical angle, that's congruent. Okay, to determine x when angle 5 and angle 6 equal that, respectively. So 5 and 6, you can see that these are a linear pair. So you just add them up and set them equal to 180. And you would solve this equation. 15x plus 5x is 20x. 10 plus 30 is 40. Equals 180. Subtract 40 on both sides, you get 20x equals 140. Divided by 20, and you get x equals 7. Okay. Now, here are some converses for you. Okay, basically just saying if two lines are cut by a transversal, so that corresponding angles are congruent, the lines are parallel. Basically taking the converse of everything I just said. Right? If two lines are cut by a transversal, so the alternate interior angles are congruent, the lines are parallel. If alternate exterior angles are congruent, lines are parallel. Okay. Now, what I'm going to do, okay, I should say this, I have a couple other videos I've made. Okay, those are not required to watch, but if you have questions on certain topics, you can watch those videos and that might help clear things up a little bit. Okay, and so the last thing I'm talking about here, the converse statements in each of those end in, then the lines are parallel, because we do not know the lines are parallel. We are proving it. So here, using this, okay, find the measure of x and the measure of this angle, so that the lines are parallel. Well, if you look at these are corresponding angles, so I'll be using the corresponding angles converse. Okay, so we know that those would be congruent to each other. So we have 8x plus 4 equals 9x minus 11. And I'll just solve this equation. Subtract the 8x on both sides, and I'll get x left over here. Add x over it, and you get x equals 15. So if x equals 15, then these angles are parallel. But I'm not done yet. I do need to find the measure of this angle, so I can substitute the measure of angle RSU, which is this one right here, should be equal 8 times 15 plus 4. Well, 8 times 4 is 45. Okay, let's see if we got going. No, it's just 8 times 4 is 60. So 60 plus 60 is what, 120, so we get 124 degrees. Okay, should we use the calculator just to double check our math so we are not wrong? Okay. 8 times 15 is 120. Yep, we're good. So 124, x equals 15, then the angles are parallel, and the lines are parallel. Okay, and that's 3.1 through 3.4 for you for the class. Okay, if you have any questions, please email me. Come to the live with email, but watch this video first, and I'll also be sending you some other videos as well. Okay. Let me just minimize this bad boy here. Oops, how do I stop the recording?